Welcome to an introduction to the adjusted present value method for valuing projects and firms. In this tutorial, we'll introduce the basics of APV and how it is used. There are different ways that APV is done. First, let's talk about project valuation. For project valuation, in this case, when the financing is very specific to the project, we tend not to use the weighted average cost of capital, but rather use the APV approach. Some examples are real estate, where there's a mortgage on the property; infrastructure projects, where there may be government-sponsored financing specifically tied to the project. In each case, the debt is paid off over the life of the project, so it's a non-constant percentage of market capitalization. Another example is firm valuation in LBO, leveraged buyouts. Here, the buyer is typically using a high level of financing up front and plans to pay down the debt and sell up the asset at some future date. Finally, we use it also in firm valuation when a firm is projecting a specific dollar level of debt financing that is different from the assumption that debt is a constant percentage of capitalization expressed in market value terms. Let's look at each one of these cases and how we would do APV in each case. Let's look at how we would use APV in project valuation. We would start with the unlevered value of the project. Here we would forecast the unlevered cash flows for the life of the project. We would then calculate a terminal value, which in this case would be the recovery of net working capital and or the sale of the asset. Then we would discount the unlevered cash flows using the unlevered cost of capital. The result is the unlevered value of the project. Next, let's look at the value of the tax shields. Here we would have to forecast debt levels for the life of the project. We need a very specific forecast here. Then we would forecast or calculate the tax shield, which is usually, but not always, the interest times the tax rate. Discount them at the appropriate risk-adjusted discount rate, usually set as the required rate of return on debt, KD, but also could be higher. The result is the value of the tax shield. We would say that the value of the project is the value of the unlevered value of the project plus the value of the tax shield. Here we see the process of forecasting the unlevered cash flows for the life of the project. We also calculate the terminal value, which would be the recapture of net working capital and the possible after-tax proceeds from the sale of the asset. All flows are discounted the unlevered cost of capital to get the value of the unlevered flows. Next, we estimate the value of the tax shield. Note, to do this, we need the interest payments, which means we need to forecast the debt levels at each point in time. We can do this when we're dealing with project-specific financing. This would be the case with a real estate project where there is a mortgage specifically tied to the project. It would also be the case with an infrastructure project where there could be project-specific financing. In these cases, the project life could be quite long. Once we have the interest payments, we can estimate the tax shields over the life of the project. There is no terminal value, and the tax shields get discounted at the required rate of return to debt to get the value of the tax shield. Finally, the value of the project, debt plus equity, is equal to the value of the unlevered cash flows plus the value of the tax shield. Now let's look at how we might do firm valuation in the case of a leveraged buyout. Here, once again, we start with estimating the unlevered value of the firm. We forecast the unlevered flows until the planned date of sale. At the planned date of sale, we estimate a sale value based on a steady-state free cash flows and a growth rate. Here we assume that the firm is refinanced at the optimal capital structure. For the terminal value, we choose WACC as the discount rate to estimate the sale value. At this point, everything gets discounted back. The unlevered flows and the sale value all gets discounted back to today using the unlevered cost of capital. The result is the value of the firm without the tax shield. Next, we value the firm's tax shield only up to the date of sale. We forecast debt levels until the sale date, estimate the tax shield. Now, there is no terminal value for the tax shield, since the value of the future tax shield beyond the sale date is captured using the WACC and the terminal value above. We discount the tax shields that we do have at the appropriate risk-adjusted discount rate, usually set as the required rate of return on KD. But this would be a highly levered transaction. The tax shields could possibly be a little more risky than usual. Once we discount them, the result is the value of the tax shield until the date of sale. Finally, the value of the firm is just the unlevered value of the firm plus the sale value at the end plus the value of the tax shield. Here we assume the firm will be purchased with a high percentage of debt, with the idea that the purchaser will restructure the operations of the firm to increase the value. In this situation, the purchaser of the firm will plan on selling it or doing an IPO at some future date. So the way value is created here is that the purchaser buys the firm with a lot of debt, fixes the operations of the firm, and uses the cash flow to rapidly pay down debt. At the end, when the firm is sold, the purchaser moves the capital structure to the optimal capital structure, and this would stay in place for the future. So in valuing the firm as an LBO, we want the unlevered cash flow to reflect the operational changes over the holding period. Here I just assumed a holding period of 5 years. Also, since during this period capital structure is not constant, we could not use the WACC approach to value the firm over this time period. Hence, we want to use the APV approach. However, since at the date of sale we're assuming the firm will again return to the optimal capital structure, we can use the WACC approach to find the sale value of the firm at the end of the holding period. Here we have the unlevered cash flows. To calculate the sale value, we need the steady state free cash flow. We discount the unlevered cash flows using the unlevered cost of capital. We calculate the sale value using the steady state free cash flow, the WACC, and the steady state growth rate. The sale value also gets discounted at the unlevered cost of capital. For the tax shield, we forecast the debt level for each time period, and the corresponding tax shield is just for the holding period. All the value of future tax shields beyond this point are embedded in the weighted average cost of capital terminal value above. These get discounted at the appropriate risk-adjusted discount rate. Here I've used KD, but it could be higher. The enterprise value is the value of the unlevered cash flows during the holding period, the present value of the sale value, and the value of the tax shield during the holding period. For valuing firms, the approach is similar to the weighted average cost of capital approach, but we value two parts: the value of the firm if it were unlevered, plus the value of the tax shields for the forecasted amount of debt. To get the unlevered value of the firm, we forecast the unlevered cash flows out until steady state, estimate the terminal value based on steady state growth rate, discount the unlevered flows using the unlevered cost of capital. The result is the unlevered value of the firm. Next, we need to find the value of the firm's tax shields. Here we forecast debt levels until steady state, estimate the tax shield, usually just interest times the tax rate for each year, including steady state. Then we estimate the terminal value for the tax shield based upon a steady state growth rate in the tax shield. Discount all of these at the appropriate risk-adjusted discount rate, usually set as the required rate of return on debt, KD, but it could be higher. The result is the value of the tax shield. Finally, to get the enterprise value of the firm, we take the unlevered value of the firm plus the value of the tax shield. Okay, this is really all about the tax shield. So what we need to do is forecast out the tax shield for a forecast horizon for specific debt levels. Next, we need the tax shield all the way out. So now it is all about what you assume for the debt level of debt all the way out in the future. There are three cases we will look at next. First, we'll assume if debt is a constant dollar amount, same dollar amount forever. Second is debt is a constant percentage of book value. It grows at a constant rate. Finally, debt is a constant percentage of market value is the same as the WACC. So in each one of these things is the assumption we would make about the terminal value. We estimate the unlevered cash flows out to a point in time when we reach a steady state. Same as in the WACC approach. Calculate a terminal value assuming that the unlevered cash flows are at steady state and will grow at a constant rate. For the tax shield, we estimate the tax shield out to the steady state. Now this requires a specific forecast of debt so we can calculate interest in the tax shield. For the estimate of the terminal value, it depends upon what we will forecast as the future debt levels. Here we assume that the steady state dollar amount of debt is constant. Therefore, the tax shield doesn't grow, and the terminal value of the tax shield is just the terminal value with a zero growth rate. The enterprise value is then just the value of the unlevered cash flows plus the value of the tax shield. Now let's see what happens if we assume that debt grows at a constant rate. Here, once again, we estimate the unlevered cash flows out to a point in time when we reach steady state, calculate a terminal value assuming the unlevered cash flows are at steady state and will grow at a constant rate, and discount everything back at the unlevered cost of capital. For the tax shield, we estimate the tax shield out to the steady state. Note this requires again a specific forecast of debt so we can calculate interest in the tax shield. For the estimate of the terminal value, here we are assuming that debt, and as a result the tax shield, will grow at the steady state growth rate. This would be the case if the firm adopted a debt policy of debt as a percentage of book value. Once we have the terminal value of the tax shield, we discount everything back using the required rate of return on debt. The enterprise value is the value of the unlevered cash flows plus the value of the tax shield. Now let's see what happens in the APV model if we assume that after some steady state, debt is a constant percentage of market value. Well, we start once again. We estimate the unlevered flows out to a point in time when we reach the steady state, same as WACC. Calculate a terminal value, assuming at this point the firm assumes a constant capital structure consistent with the assumption we use in WACC. For the terminal value, we estimate a sale value using steady-state free cash flows, steady-state growth rate, and the firm's weighted average cost of capital. All of these flows get discounted back at the unlevered cost of capital. For the tax shield, we estimate the tax shield out to the steady state. Note this requires again a specific forecast of debt so we can calculate interest in the tax shield. However, since we use the WACC approach above to estimate a sale value at the end of our forecast horizon, the value of all the future tax shields is embedded in the sale value. As such, there is not a terminal value for the tax shields. The tax shields we do have get discounted back at the required rate of return in debt. The enterprise value is the value of the unlevered cash flows during the holding period, the present value of the sale value, and the value of the tax shields. So basically, in the APV world, the enterprise value of the firm is just the sum of the unlevered value plus the value of the tax shield generated by debt. But how we do it depends on whether it's a project, an LBO, or just valuing the firm.